Hi everyone. So I want to finish the lesson 6 questions on a video for you since unfortunately I am not able to be there today, and I want to give you, another day of practice. So please, maybe try the questions first since we did go through lesson 6 together yesterday in class, and then you can watch this video or look at the answer key posted on Canvas to see how you did. So if you have not tried number 3 yet, I want you to pause the video and give it a try, and then, start playing so you can go over it with me. So in number 3, we have a survey of 40 high school students. It was done to determine how many of them liked fresh fruit for lunch. The school is going to offer an option of fresh fruit if more than 30% of students like fruit. Of the 40 students surveyed, only 9 of them stated that they liked fruit with their lunch. So simulations were done with a population proportion of 0.3 and a sample size of 40 to see how likely a sample of 40 would have only 9 who liked fruit. So again, the goal here is to see, was our one sampling of 9 out of 40 students who liked fruit, was this likely? So if we used a computer simulation and did 100 simulations, that's what we're looking at here. And again, each of these dots would represent, one survey of 40 students. How many said they liked fresh fruit out of the 40? And, it looks approximately normal, sort of centered around 0.3, which is what they're hoping, the option is here. They're hoping 30% of students say that they like fruit, and they give you a mean here of 0.307 and a standard deviation of 0.071. Okay, so let's look at the first question here. So given this output and assuming a 95% confidence level, we're being asked to calculate the margin of error and the interval containing the 95%. So margin of error, that first value here, a lot of times you'll see us write MOE for margin of error. It's just 2 times the standard deviation. So let's take our standard deviation and multiply it by 2. So that was the 0.071 value. If I multiply that by 2, just realized I don't have my calculator in front of me. Give me a second. So 2 times 0.071, we get a margin of error of 0.142. And now if we take that margin of error and use it to calculate the interval containing 95%, I need to take my mean, 0.307, and add and subtract that margin of error. So if I first, let's start with the left side. So we'll subtract 0.307 minus 0.142. Zoom in here a little bit. 0.307 minus 0.142. We should get 0.165. 2, let's now add it. 0.307 plus the margin of error. So 0.165 to 0.449. Okay, so that is our interval containing 95%, sorry guys, of our data. Now, and again, I guess I'll box this in 2. We also had to find the margin of error separately to start. So, should the school continue to serve fresh fruit for lunch even though only 9 out of 40 students surveyed initially that they liked fresh fruit? So, let's determine if our 9 out of 40 was likely. So first of all, let's look at 9 out of 40 as a decimal. Since our interval is a decimal, this would give you 0.225. So since 0.225 is a value that would fall in the interval, we're going to say, yes, this is likely. Since 0.225 falls within the interval containing, containing the middle 95%. Okay. Now, there are 2 practice questions here. Why don't we take a look again? If you haven't tried the next question, pause the video, give it a try, and then turn it back on so that we can review it together. So 70 students that go to Jericho High School were randomly selected to participate in a survey about their favorite beverage. 35% responded that they like soda over water. So a simulation was run 300 times, each with a sample size of 70, and based on the premise that 35% of the students would prefer soda over water. So they made 35% the average, the middle. And you can see here, based on this, normal looking distribution, that 0.35, 35%, is the center of that. And you can see from the readout here that 0.351 is the average to the distribution, and the standard deviation here is 0.058. Okay, so we're going to use the results of the simulation to determine first the plausible interval that would contain the 95% of data. So this is where we're going to take our mean, so 0.351, and we're going to add and subtract 2 standard deviations, or our margin of error. So let's calculate that. So 2 times 0.058 would be 0.351, our mean, plus or minus the margin of error, which comes out to be 0.116. Again, in this case, they didn't ask you to actually calculate the margin of error, but that would be the value for it. And then 0.351 minus the margin of error would be what I would calculate first. And we should get 0.235. And then let's look at the other side here. So 0.351 plus our margin of error. And that we should get 0.467. It did say to round here to the nearest hundredth. So let's just take a moment to do that. So 0.24 to 0.47. So that is our middle 95% interval. If something falls within this interval, we would say we are confident. If something falls outside, not so confident that's going to happen. Or likely to happen inside the interval, not likely to happen outside the interval. Follow-up question to that says, school administration will only continue to stock the vending machine if at least 50% of students prefer soda over water. Describe how this simulation could be used to support the decision to remove soda from the vending machines. So 50% would be 0.5, right? So again, think about this interval on a number line. So 0.24 to 0.47 is our 95% interval. 0.5 would fall, outside of that. So they're saying, how can we use this data to support the decision that they're just going to remove soda from the vending machines, since 0.5 is not in the interval containing 95% of the data. The school should remove soda from the vending machine. Right, so they were only going to keep soda in the machine if 50% of the students, or 50% or more, at least 50%, said they preferred soda, but the highest preference there would be 0.47, or about 47%, so 50% falls outside of that interval. Okay, and there's one last question we'll look at together on this video, and again, I will repeat myself one more time. If you've not had a chance to try it yet, give it a try, pause the video, and then come back and we'll look at it together. So this last question is talking about a beverage company, and they're considering whether or not to produce a new brand of cola. The company's going to launch their product if at least 25% of cola drinkers will buy it. 50 cola drinkers are randomly selected to take a blind taste test of products A, B, and the new one, the new product. 9 out of 50 participants preferred the new cola to products A and B. So 9 out of 50. The company then devised a simulation based on the requirement that 25% of cola drinkers will buy the product. So they made 25% the middle, right? Which I guess you could see here, or looks about, I guess that would be 0.24. But 25% definitely looks like it's centered around that. And each dot on the graph represents the proportion of people who preferred Stephen's new product, each sample size 50, repeated 100 times, right? So this is the computer showing that one survey that they did that they got 9 out of 50, done 100 more times, centered around the average of 25% saying they would buy the new product. You can see the average and standard deviation given to us here. So now assuming that the set of data is approximately normal and the company wants to be 95% confident of the results, does the sample proportion obtained from the blind taste test, which was the 9 out of 50, fall within the margin of error developed from the simulation? So let's just take that 9 out of 50. Again, that's our sample proportion, our p hat, 9 out of 50. That would be about 18%. So does 18% fall within the 95% confidence interval? Well, the only way to determine that is to calculate it. So 0.247 plus or minus 2 times the standard deviation. So 0.247 minus that, and 0.247 plus that gets us to an interval of about 0.123 to 0.371. So 0.18 would fall in that interval. So we can say here, yes, 9 out of 50 does fall within the margin of error. Then it says the company decides to continue developing the product even though only 9 out of 50 participants preferred its brand of cola in the taste test. Describe how the simulation could be used to support the decision. So we could say here, since 9 out of 50 falls in the interval containing the middle 95%, that would be their reasoning to continue making their product, because it is a likely outcome in this 95% confidence interval. So that would be their reasoning. So since 9 out of 50 falls in the interval containing that middle 95% of data, the company should continue making the product. Okay. All right, everybody. So again, not ideal that I can't be with you today. I apologize. We are on another quarantine with my one son, but I will be in tomorrow. So what I just ask you is, once you've gone through these 3 questions, you can, at this point, definitely attempt the homework for lesson 6. It is only 2 questions. That is due tomorrow, which would be Friday morning by 9 a.m. on Canvas. And since I can't have extra help today, I'm going to offer an additional extra help next week. So instead of 2 extra helps next week leading up to the test, I will have 3. Okay, unfortunately, I can't have one Friday morning, but I will send this message out to you also on Canvas to let everybody know that there won't be extra help tomorrow. All right, guys, I hope you have a great day, and I'll see everyone on Friday.